Welcome to INDUSTRY.forward EXPO 21. As you notice, this session is going to be in English. My name is Christian Fischbach, and I have the pleasure to welcome Meir Veisberg, CEO of Sparrow. Welcome, Meir. Great to have you here.
Thank you.
Stock less, but have more. Sounds a little bit like you've solved the spare part paradoxon. But in fact, Meir will show us how we can achieve this by using the power of data analytics, I guess, data algorithms, and connected networks. But now I don't want to waste any more time because I'm really curious about the magic Meir will show us. Meir, the stage is yours.
Thank you, Christian. Let me quickly share my screen, and thank you for giving me the floor to speak about what we do and about how data and algorithms can really reduce downtimes and costs related to spare parts. We'll try not to be too technical in this conversation, but it is important for us. We're very passionate about this topic. We believe that there's currently a lot of waste in both downtime and in stock and costs due to missing data and misapplied algorithms. And we really want to help solve it. Before I get started, just a few words about us. So we're Sparrow, a Berlin-based company. We offer 3 modules for improving spare parts availability while reducing costs. The first looks at improving the quality of spare parts data. The second is an analytics layer that helps optimize spare part stocks. And lastly, as Christian also hinted, we have a spare part pool that is a connected network connecting suppliers and operators to each other, but also operators to each other and operators internally, with the aim of reducing the global stock of spare parts. Now, let me get to my talk. So what we know, and we've been tracking this for years now, and the numbers are only getting worse, is that most cases, or 45% actually, of industrial operators will say that they have issues with downtimes due to missing spare parts. Actually, these 45% also report that they have their main concern about spare parts is downtimes. For people coming outside the industry, this would be an easy problem to fix, right? Because if you have so many downtimes due to spare parts, well, the natural response to this would be, okay, so it's common sense, just go and buy more spare parts. But that's not actually solving the case. So when we look at our customers' stocks, and this is also noted in academic research, but we now have a lot of data from years of working. About 75% of spare parts are rarely used. So 75% of spare parts have been consumed less than once or less in the last 12 months. Many of these, typically about 50%, have not been used in the last 3 years, 5 years, 10 years. So it's not a problem of not buying enough spare parts. Companies are buying a lot of spare parts, as we can see. Okay, so now we know we need to buy the right spare parts. But how do you do that? And that's where we come in. We think that buying the right parts is easy. You just need to not make these mistakes, right? You want to be right, just don't make a mistake. Don't be wrong. There are 3 kind of groups of mistakes that we've seen repeated. And in our next 15 to 20 minutes, we'll talk about these pitfalls, these mistakes, and how best to avoid them, how we've seen companies avoid them. These are typically grouped into 3 levels of, or 3 groups of pitfalls, mistakes that we've seen. One is having low quality spare parts data. So not uniquely identifying a part, for example. Second is having intuitive planning. So not actually using data and algorithms in the way they should be used to plan for the future. And lastly, it's planning for spare parts in a silo, or managing spare parts in a silo. And for us, that's very important. I'll give a few words on that in a second. As you can see, these pitfalls are actually overlapping. These groups are overlapping. And the reason they're overlapping is because they're actually all interfering with each other and exasperating or making the other ones bigger. And I'll talk about that as well. A few words about why the silo approach is the biggest problem, one of the biggest problems for us. We focus on the concept of pooling as we believe it's the best way to optimize spare parts. If we take a step back, the demand for spare parts in every site, everywhere in the world, anywhere from your car, but especially in an industrial setting, is probabilistic. We don't know how many parts we'll need. And that's just typical to how parts are malfunction, right? They malfunction with a probability of once in every 10, 15 years, 1 million hours of operations, etc. When you pool demand and supply for spare parts together, you make it better. You make it the probability of having the right part higher, and you also can stock fewer parts. Let's go right to the pitfalls. The first pitfall we see is, and this is, I think anyone who's worked with a spare part list will automatically identify this, is actually not uniquely identifying spare parts. And we've all seen a spare part list that has a line that might say electrical motor by Lenze. That's great, but Lenze makes billions of different configurations of motors. You can't really buy that spare part again. You can't find it if you need it, etc. Actually, we typically find 5 to 15% of any customer data set we see full of duplicates. And that has both issues with them finding the part on the shelf, but also you are double stocking when you have duplicates, of course. That the causes for this are very human, right? It's the identifiers weren't there in the recommended spare part list from the OEM, or the data was entered in the wrong field, like the ID is in the description field. You can't remove duplicates if the ID is not in the right place. Or there isn't a catalog. There's a stock data set, there's a procurement data set, but there isn't a central catalog that actually manages the data for spare parts. What we've seen the best-in-class teams do is use technology platforms and or processes to make sure that each part is uniquely and easily identifiable. The second data pitfall is not keeping the parts data up to date. So it's actually quite easy to understand why it's hard to do. If you have a stock room of 50,000 spare parts, it's really hard to keep an eye on each one of these 50,000 parts every 6 months to a year. It's very time-consuming, resource intensive to do. The impact of that is that generally 10 to 20% of every customer data set we see has what we call unknown obsolete parts. So these are parts that the maintenance teams, the procurers, the spare part managers didn't know were obsolete, even in the best companies we see. These parts can't be sourced in for normal operations, for normal maintenance, but worse than that, if time comes for an emergency, it's even harder to find them then. What the best-in-class MRO teams we've seen is try to use automatic notification technology and systems to keep themselves notified with what is push messages. So they are subscribed to multiple different newsletters and the likes. There are some platforms, we also offer something like that, where you can, every 6 months to a year, someone reviews all of your data and makes sure that your parts are up to date. I'd like to talk a bit about planning pitfalls now. The first planning pitfall is actually not leveraging historic data enough. That's typically because there isn't historic data. So spare part consumption, and that's the most important historic data for our purposes, right? We want to project to the future how many spare parts we'll need. The past is actually a very nice indicator of the future, if not a perfect one, of course. But many companies will not track spare part consumption. Definitely not track in the way that we find is the best way. So actually track which part was used and for which purpose, for which machine. In some cases, it's a greenfield project, of course. There is no history. In some cases, data exists, but in silos. So a company of multiple sites will have data about the specific part consumption from from a historic project, but that data aren't shared. Lastly, of course, you need to have the right tool for tracking. Today, many of our customers will already have ERPs that, such as IBM Maximo and the likes, that allow these kind of tracking. But if you have an outdated ERP or still using Excel for managing your spare parts, you may not be able to track this consumption. The impact is you can't use reliable data for planning. The best in class that we've seen keep track of each time a spare part is used, and then why it was used, and then use that data for better planning. So, for example, create this histogram of how the distribution of part consumption over time, and allow us to kind of get a view of the history and project for the future. Here, it's important to understand that we have to track the reason a part was used. If 50 items were taken out of the warehouse for a maintenance operation, it's not as if 50 items failed. So understanding the reason for failure is very important. The second planning pitfall is applying the wrong heuristics, right? We can't always know how to do things. We don't have the time. We use heuristics. Sometimes these heuristics are wrong or not enough. For example, a common heuristic we see is taking a fixed percentage of the total install base and saying, for example, I have 100 motors installed, I should keep 1%, 3%, 5% of these as a minimum. That's generally correct on the population of spare parts. It is correct that at the end, we'll get to something like 1 to 3 to 5% of the install base as a spare part. That is not the case per spare part. Each spare part has a different failure pattern, right? The second heuristic is using recency, right? So recent history and then using that for future planning. So for example, we used 2 last year, we need to buy 2 this year. And again, it's not completely wrong, but it's also not completely right. It's more important to look at consumption over time, understand the pattern, and then work towards the future. The best in class actually try to use reliability science and try to understand per part the failure pattern, how that looks today, how it's likely to look in the future as the machine and part degrades, and then adjust their planning accordingly. The planning pitfall 3 is a combination of the planning and data. As I said, these pitfalls overlap, and that's not having enough of the right attributes for planning. To make good planning for spare parts, MRO teams need to understand both the probability for failure and how quickly can they get a replacement part, or in other words, what is the lead time? These data aren't always easily available. In some cases, you can get them from the manufacturer, as noted here on the right. You can see the MTBF, the mean time between failure, noted as 1 million hours, and that's very useful information. But it's not always there, and it's not always easily attainable. So, for example, our team developed an algorithm to estimate these MTBFs in cases where they're missing. And that's really important because if you don't have that and you don't have historic data, you are actually operating in the blind. You can't make a good judgment towards the future. And the second thing is the lead time, where, of course, if you don't know how long it takes to get a part, it's very hard to plan how many parts you need to keep in stock, because if it takes 6 months to get a part, you need to maybe stock 3. But if it takes 1 day, you maybe need to stock 1. So getting that data and keeping that data up to date, and actually even vetting that data. So again, what we do is we typically look at the lead times that we have for the spare parts where we look at it. And then we look at historic procurement data for these spare parts and these manufacturers and these suppliers and try to estimate what is the probability that this lead time is actually correct. So is it really going to be 3 weeks? Based on history, 90% of cases were more or less. And then this helps our customers plan better. Next is the silos pitfall. And it also corresponds with the data issue. And that's keeping local spare parts catalogs, meaning not sharing the data about which spare parts we have, not keeping a unique material master across all sites of our company. That typically is done, again, for very human and natural reasons. So multiple teams enter data, each one in different sites. There isn't a central process or function or technology that aligns all these catalogs. And in some cases, there isn't a shared ERP. So a lot of companies grow through acquisitions and other inorganic growth. And then you have a mixture of ERPs, and these don't talk to each other, resulting in multiple catalogs. The impact is, first and foremost, it makes it very hard to actually use scale for procurement, and procurement is very important for using costed in MRO purchases, of course. Maintenance teams are less able to share parts in emergencies. As I said, we firmly believe in the idea of pooling spare parts and sharing resources. When different catalogs are there, and we see this every time we look at a company, we see that each site will call the part differently. Sometimes it's a language issue, sometimes it's just timing, and sometimes it's just a process, but companies will call the same part differently in different sites. And lastly, central spare part planning is not possible. And again, if you think of a company with multiple sites as a network, as a pool of spare parts, you need to be able to plan how many spare parts are needed in the entire network. And to do that, you need to have a central catalog, or at least a central naming convention. If you don't have that, it actually blocks any central planning effort. What we see is that the best-in-class MRO teams, maintenance teams, generally leverage automatic data harmonization. And there are tools and products out there to do it that help you create a central catalog. There's almost always time and effort required, but that pays off tremendously in cheaper procurement and in better planning. The second pitfall is planning locally. As I mentioned before, it is actually a lot better to plan centrally, or at least partially plan centrally for those parts that are shared between the different sites. But what we see is that actually in almost every company we spoke to this point, planning is done locally by the site maintenance team. Sometimes even within a single site, each line will have individual planning and individual stocks. And that's sometimes an issue of tooling. Again, the software can only plan locally. Sometimes, and most often the case, the MRO, the maintenance team, want to manage the risk locally because they feel that they are responsible. Hence, they need to have to own that risk. Sometimes they don't have the right metrics, the right KPIs. So they have local KPIs and local responsibilities, and again, don't want to look at the big picture of the entire company. And finally, as I said before, if they don't have a shared ERP, it's very hard to plan as a group. The impact is that companies miss the opportunity to reduce stock through pooling. Right? That's immediately the case. And even if you don't care too much about the pooling and reducing costs, in the event of a downtime, it's really hard to then go to a sister plant and find the part you need, because they may not have it, even though they could have had it for you, or etc. It actually becomes really hard to leverage the pool. The best-in-class MRO teams plan centrally and basically create a company-wide spare part pool. And that means that if you look at a company with 5 to 10 to 15 sites, as some of our customers have, they will identify the demand for spare parts across all of these sites, and then allocate the supply accordingly. So if 10 sites need 10 parts in the next year, or could need 10 parts in the next year, you don't need to stock 10 parts, one per site. You can stock 2 or 3 and have a smart logistics solution to convey the parts. A bit of how this actually looks in reality. So this is an example from a stock room we recently worked on for Sparrow customer. And this is what we typically see. So this was a spare part room of about 4,000 parts. About 840 of these parts had wrong identifiers, models, or manufacturer names, making it very hard to source them and find them. A lot of attributes were missing for these. For example, like lead time, MTBFs, etc. So for about half of these, we could add more attributes that were missing. We found 9% duplicates, which result directly in overstocking, and about 550 parts. So again, roughly 10% of their parts were obsolete, or unknown obsolete. So the first time they knew it. So there were more obsoletes, but some of these were already identified, but there were 550 that were not identified. And again, looking at a best-in-class example of actually using a data and algorithms to reduce stock. So this is a company with three sites that started with a spare part stock of 8.5 million, and through a journey that looked at both pooling, optimizing, and combining optimization and pooling, could reduce as much as 3.5 million in their spare part stock without increasing the risk of downtime, even reducing it. And that saves a lot of money. It reduces a lot of stock, working capital, but also reduces the cost. Of course, spare parts are an expensive item to hold, due to storage, insurance, of course, obsolescence. Typically, we take it as 20%. So that actually releases a lot of money to the organization. And with that, I'll leave you with that. So basically, if you can quickly summarize the things we talked about. So we went through the common pitfalls of data, intuitive planning, and a silo approach. And we can see that once avoiding these, and there are tools today out there and processes already out there established, companies can reduce their stocks quite drastically while keeping or increasing their availability. And I thank you. And I'll take questions now, I think.
Yeah, Meir, thanks a lot for these insights. I think the most of us will know the shown pitfalls you had in your presentation. That's of course why we have some questions. Let's have a few on this. The first one is companies looking to improve their current spare part management practice. What do you think are the main challenges they have?
Yeah, so obviously there are a lot of technical challenges. So how do you actually get data for better spare parts? What are the algorithms used? But these can be solved, right? So there are companies like ourselves that can help with that. The biggest challenge is always change management and process management, right? So in the case of pooling, for example, you have local teams wanting to keep the power and the control. In the case of data, it is how you keep data correct and up to date once you've had a cleaning process. And what we've seen, these challenges are difficult, but actually can be solved through having better, simpler technology and having the right incentives put in place.
And what do you think would be the best step to start with?
Generally, we recommend to start with the data harmonization and cleaning, because that allows, basically it makes sure that everything that comes after that is on firm ground, is using correct data, and otherwise you have to go back and redo the work in many cases.
Another question is, how would the methods you showed us apply to companies having very old parts in their plants?
Yeah, so the age, we see this quite a lot. A lot of companies tell us, and this is becoming more and more frequent, that their production lines are staying alive longer than they anticipated, and they now have spare parts on their shelves for 20 years. And they can't even have the original data anymore. And it is a challenge, but what we saw is that unless there is a plan for replacing this production line, this machine, you have to start now, because it's only getting harder and harder as the machine or the spare part ages. And a solution like this helps you at least identify where your risks are and where you should go to actually focus when you get obsolete parts, when you do upgrades, where you should go.
There's one really basic question. What are the offerings Sparrow has for these problems? Is it consulting? Is it software?
It's software. Yeah, we're a software company. Of course, we'll provide good project management for installing our software for onboarding companies, but we are a software company. For example, our data cleaning is an algorithm that takes data we have sourced from catalogs of manufacturers and algorithmically matches it with the data set of the customer. We can't do this work manually. We have to use a lot of technology.
One of our viewers tells us they haven't collected that much data about their spare parts yet. Can any sophisticated analytics then still be performed?
Yes. So as I said, we see this quite frequently, and our way to overcome this is why we spend a lot of time understanding the parts themselves. So if someone doesn't have historic data about a part, we do find the mean time to failure from the manufacturer. We do already have a our own historic database of how parts are used, and we can augment a lot of cases. We can fill a lot of holes where data aren't there. It's actually quite common. Yeah.
We have quite an open question here in the board. Can you elaborate a little more on the identification problem regarding spare parts?
Yes. So what we typically see is that spare parts are listed in the stock list or the material master without what we call it is without enough information allowing you to uniquely know what is this part. So if you go to the machine and there's a failure, you identify the parts that failed, you go to your spare part list, and now you say, okay, I want to find it. You will not have enough details in that list to say, okay, this is exactly the part that failed. Or if you want to buy it, you don't have enough data to say, okay, now I can go to the supplier manufacturer and uniquely identify and buy the right part. So I know I can get the right form, fit, function. That's actually very common because to identify correctly a part, it depends on the manufacturer. There are sometimes many attributes that you wouldn't expect that you need to say. So sometimes you need just the ID, sometimes you need the ID and the model, sometimes you need the ID and the model and a list of customization attributes. And that actually varies between different manufacturers, and there is almost no way for an operator to know this. So they are forced to add a lot of data, but no one has the time to add a lot of data, so they end up not having enough.
Okay. Yeah, thanks a lot, Meir, so far. It was really interesting, new methods to handle spare parts. Thanks to everyone watching us. And I hope I'll see a lot of you guys again tomorrow. This is our last slot today. Yeah, thanks a lot. Bye.
Thank you, Christian.